Hey guys, Mr. Betts here. In another video, I talked about partial sums and how we're going to use them to find infinite sums or sums of infinite series. So I want to talk more specifically about partial sums and their relationship to the terms in the series. So just a refresher, when we say a sub n, or this might be b sub n or something like that, we're talking about a sum where the individual terms are represented by this a sub n. This is representing the individual terms that we're adding together. And then S sub n is representing the first n terms added together. So for example, A sub 3 would be the third term in the series. S sub 3 is what we get when we add the first three terms together. So I want to generalize something here real quick, because by doing this, we're going to be able to use these partial sums a little bit more generally. So we're going to be able to use it in more situations. So if we think about what S sub n represents, S sub n is going to be A sub 1 plus A sub 2 plus A sub 3 and so on, all the way up to A sub n. So we just add the first n terms together. It may not be obvious why I'm doing this yet, but you'll see in a second. So if we look at the n minus first partial sum, so the partial sum right before S sub n, that's going to be A sub 1 plus A sub 2 plus A sub 3, all the way up to A sub n minus 1. And just for consistency, I'm going to do this. So I'm going to include the n minus first term here. And you'll notice that these two partial sums are identical, with the exception of this nth partial sum has the nth term included in it. So what we can do here is we can say that all of this right here, let me try that again, all of this right here is going to be the n minus first partial sum. So we can replace this with S sub n minus 1. And so another way of getting any partial sum is essentially taking the partial sum before it and adding on next term. Now, this might seem kind of obvious, but by rearranging this formula right here that I just wrote down, we can actually use it to take partial sums and use it to find the individual terms. So this would be useful in a problem where we're given information about a partial sum and we want to know information about the individual terms. So for example, if I want to know the nth term in a series, then I can take the first n terms all added together and subtract the first n minus 1 terms all added together. So I think this is a little more intuitive if I throw some actual numbers in here. So let's say that we're looking for the 10th term in a series. So I want to know, what is the 10th term in the series? And I know what the 10th partial sum is. So this is what we get when we add the first 10 terms together. I just want to subtract out what we get when we add the first 9 terms together. So it's a kind of an intuitive idea, but we can use this generally by keeping n's in there, or k's, or whatever variable we're using here as our counter variable. And so this formula here can be very useful if we're given information about a partial sum. So in this example here, we are told that for some particular series, the partial sum is given by this formula. So if I want to know what's the sum of the first 10 terms, so the sum of the first 10 terms I get by plugging 10 in, and that's going to be 10 over 20 plus 3. So 10 over 23. This question, though, is asking for what is the 10th term itself. So if I want to know what the 10th term is, I know the sum of the first 10 terms. What I want to do is take out the first 9 terms. So if I can figure out what S sub 9 is, that's the sum of the first 9 terms, and that's going to be given by this. And so to find the 10th term, we just subtract those. So we take the sum of the first 10 terms minus the sum of the first 9 terms. And let's say this is a free response question. There's really no need to simplify that. You can get a common denominator and actually subtract. I don't know what that answer would be, and we don't really need to know. So this right here just gives us a way of finding the individual terms when we know information about the partial sums in a series.